Electric motors can be found in many areas of our everyday lives. Although there are various types, all of them use the magnetic effect of electric current. When current flows in a wire, a magnetic field is induced around that wire. The strength of the magnetic field thus generated depends on the intensity of the current flowing in the wire and the distance from the wire. The magnetic field generated by the current can be further strengthened by winding the wire into a coil. The coil thus made is the electromagnet, which is found in all electric motors. The strength of the electromagnet and the position of its poles can be adjusted within the current flowing through it. The electric current can create a magnetic field, but the magnetic field can also produce electric current. This phenomenon is called electromagnetic induction. Electric current can only be induced by a changing magnetic field. If the magnetic field changes near a coil, a voltage is induced in the coil and an electric current is generated. This current will have a magnetic field, so the two magnetic fields can interact with each other. This phenomenon is used in some electric motors. There are two main types of electric motor: direct current, or DC, and alternating current, or AC. As their name suggests, DC motors are powered by direct current. Their stator is a permanent magnet, and their rotor is an electromagnet. The current is applied to the rotating coil through a sliding contact and carbon brushes. As a result of the electric current applied to it, the coil becomes a magnet. It turns in order to align itself with the polarity of the permanent magnet. However, before aligning itself in the correct direction, the polarity of the electric current in the commutator is reversed. Accordingly, the coil continues to rotate toward the opposite pole, and this is how it keeps the motor rotating. The other main type of electric motor is the AC motor, which consists of synchronous and asynchronous motors. In synchronous motors, alternating current, which changes direction periodically, is applied to the rotor. This current can be obtained either from the mains electricity or electronically. A simple electronic circuit ensures that the electric current does not alternate in the same phase in the coils of the stator, which generates a rotating magnetic field. In these motors, the magnet of the rotor tries to follow the rotating magnetic field of the stator, so it rotates with it. Synchronous motors can only operate at a speed that corresponds to the frequency of the electric current that drives them. If too much load is suddenly put on the motor, the rotor and the stator poles will fall out of synchronization, and the motor stops. These motors are not self-starting. They require a starting mechanism. Most synchronous motors are started by an induction mechanism, and only switch to synchronous mode when they reach synchronization speed. Since alternating current is generated from direct current by an electronic circuit in modern electric vehicles, these motors can be considered as DC motors. They are also called brushless DC motors or BLDC motors. The principle of operation of asynchronous motors is based on the phenomenon of induction. They also contain two fundamental parts, a stator and a rotor. The stator consists of several coils, to which an alternating current is applied. The rotor can be a simple metal cylinder, but it is usually a coil that does not receive current from outside. It will be induced in it. The alternating current in the coils of the stator does not flow in the same phase, so a rotating magnetic field is generated around these coils. This rotating magnetic field induces an electric current in the rotor. The induced electric current is another magnetic field around the rotor. The two magnetic fields interact with each other, so the rotor tries to align itself with the external magnetic field. However, since the magnetic field rotates, the rotor can never catch up with it, so it constantly revolves. The operation of asynchronous motors is less complicated than that of synchronous motors, since they do not stop when the load is increased. Both AC motor types have linear versions too: LIM, or linear induction motor, and LSM, or linear synchronous motor. In these types, the operation of the motor leads to translational movement, not the rotational kind. Their principle of operation is the same as that of rotating motors, except that both the rotor and the stator are aligned along a straight line. Stepper motors are useful in devices where it is necessary to know the exact angle, or step, by which the motor rotates as a result of a certain amount of electric current. Such motors move the arms of robots, or the components of photocopiers and printers. The rotor of stepper motors consists of permanent magnets, while the stator is made up of electromagnets. The electromagnets of the stator are supplied with current separately by the control electronics according to the desired angle.